A very good afternoon to everybody. Uh, Neeta is here. Michael, good afternoon. Very good afternoon to everybody. Sai is also here. I think, ma'am. Good afternoon, ma'am. And Dinesh is also here. Good afternoon, Dinesh. Narinder is missing. So, today's lecture is on non-cinematography techniques in biomechanics. In the previous lecture, we dealt with imaging techniques, which involves direct imaging. So, non-cinematography by name, you can identify that it doesn't involve direct vision, जिसमें आपके विजन का कोई यूज नहीं है. by other data, instead of your vision, instead of your recording of camera, you get very useful information by different instruments we have in biomechanics. So all those techniques जो हैं will be discussed in today's lecture. So these are popularly known as non-cinematography techniques or non-imaging techniques in biomechanics. So let's start today's lecture. Now, brief introduction of non-cinematography techniques. So what are they? So these devices involves use of sensors which does not involve direct vision. They do not use cameras. So how we get that information? They provide very useful data indirectly by using sensors other than vision sensors. So these sensors give what information? They give us information about force, kinetics, kinetic data, angular velocity, kinematic data also can be there. All these data, linear velocity, angular velocity, rotation, angles, we get by these techniques, but we are not using cameras in this technique. So that is the difference. Okay. And we also use fusion also. Fusion, what? We utilize these technology with vision in 3D capture also. We have some markers which are not meant for imaging, but they give very good useful information in coordination with 3D motion capture. So that's why third point is there. All this info in coordination with direct imaging protocols. Direct imaging protocols kaun se hai? Which I have discussed in the previous class, like 3D motion capture, video analysis. So they generate collectively very comprehensive information, and this information is very accurate and good for research purposes. But today's focus is only on non-imaging. So we'll discuss them one by one. So the first one in this kind of technology, non-cinematography technology, we have force transducers. We call them as force transducers. These are used like a gold standard. What I mean by gold standard, that they are used in each and every biomechanical lab which is dealing with sports. And the instrument in which they are being used is known as force platform. You know that. Because force platform is always there in biomechanical lab which is dealing with sports. So these are the main components, you can say, of force plate which actually measures forces. Okay, so what is that by definition? So it is a sensor that measures the force in the form of tension and compression that act on it. So what it means, it simply means that this kind of transducers or these kind of sensors can detect both push or pull. Either you are pushing it or you are pulling it. In simple words, any kind of force which you are applying on these sensors, they are going to record it very accurately. So that is the thing. And these sensors enable sports and fitness devices with real-time force feedback. Now focus on second point. Now we have some smart devices also right now, the latest ones. We call it as wearable technology. Wearable technology से क्या मतलब है? The technology which you can wear on your bodies. So this is the second part of lecture. What are those? So that wearable technologies uses these sensors, force transducers, to give you real time information about forces. So that is the latest thing right now happening. But still, the gold standard in these are still the force platform. They are not accurate as these variable technology is not as accurate as force platform. Force platform is the gold standard technique because it is very accurate. It comes at number one in accuracy. So after that, these things come because of some portability and some of that real time feedback of the forces from the ground. So I'll discuss that. You will get to know what are they. But initially, prime thing is force platform where these force transducers are used. So secondary part is this variable technology. So they are using the smart wearable devices or monitoring system capable of measuring force. So smart devices are which are wearable, and the systems is mainly force platform. Okay, so I think it is clear. And on the right side you can see the picture of different sensors, and on the next slide you will see a kind of this force sensor which is known as flexible position sensors. So what are they? So they are used in these kind of technologies, wearable technologies. Like I have given you two examples. One is footwear. In the sole you can see the force sensor. Another one are the gloves which will record the forces on around the grip of a golf racket. So these are used for specialized techniques when you want to get real-time feedback of forces from the ground. Okay, but accuracy, as far as accuracy is concerned, they are not as accurate as force platform, but still they are being used and they have very good application. So I'll discuss them later on. Now before moving further, I will let you know how these sensor works. So please focus on the diagram. This is the basic diagram of each force transducer. Basically, on the basis of construction, there are three types of force transducers we have. One are piezoelectric, one are strain gauges, and third one is load cells. So on the basis of construction, they are basically of three types, but basic construction is like this. So focus on the figure. In the center, you can see this is a crystal. So this type of, when there is a crystal inside this, the sensor is known as piezoelectric, and you can see the forces, both kind of forces it can detect. Either it will act from top or from bottom. So when force will be applied, this crystal gets deformed, and when this crystal gets deformed, it will vary its electrical properties like resistance or current, anything depending upon the sensor. So usually this change in the electrical properties will result in change in the voltage. So that will be recorded. So simply force transducer generates an output charge or voltage that is proportional to the force applied to the transducer. So whatever you force you apply, that will be converted into electrical signal. So that could be due to change in resistance, that could be due to change in current. Ultimately what you will be getting an electric signal, and that electric signal is directly proportional to the force applied, and it is very accurate. The amount of your force apply, the same change you will get in the electrical signal, and that gets detected, and then it gets get into your computers, and then you analyze that and you get the results. So this is the basic principle. Now in the piezoelectric, in the center we have crystal, or sometime bone material is also being used in some of the piezoelectric sensors. So the other two types, like load cells and strain gauges, we have some metal material inside, and when deformation happens due to force, that metal has resistance to the current, so that resistance will change, and ultimately again we'll get the change in the electrical signal. So the main idea, how it principle works, the main principle is the force you apply will impart a change in the material, in the electrical properties of that material, and that will lead to change in the voltage. So force signal is getting converted into electrical signal, and both are proportional to each other, and accuracy is very nice, very high accuracy is there. Okay, so this is the way they work. Now in the next slide, I have given some points regarding types. So three kinds of, on the basis of construction, there are three kinds of transducers, force transducers. First one is piezoelectric transducer, strain, second one is strain gauges, and third one is beam load cells. So in the piezoelectric transducer operate on the basis that when a force is applied, certain crystals, they are mainly composed of crystals or like ceramics or even bone material is also there. A charge proportional to force appears on the surface of the material. Recording the resultant voltage allows force calculation. So second one simply means that whenever force is applied, that crystal material get deformed and you will get change in the voltage, and that gets recorded, and that will help you to calculate force. Okay, and piezoelectric transducers are the one which are used in force plates because they are very accurate, they are very sensitive to the changes in the forces, and they are the most expensive. Keep in mind, so when they are expensive they are accurate, so they are always like this. So when you have expensive technology, that always mean that it will be very accurate most of the times. Okay, now the third point will tell you about that strain gauges and beam load cells. So these cells operate on the basis that changes in the electrical current occur when a metal or semiconductor is deformed. So the material used in these two strain gauges and beam load cells is either metal or some semiconductor material is there. So again it will lead to change in the current, and that will produce electrical signal. So the main idea is that piezo, there are three kinds of uh, these force transducers mainly on the basis of construction, and piezoelectric, strain gauges, beam load cells. Piezoelectric are the one which are most accurate. These are the one which are most expensive, and these are the one which are being used in the force plates. Other two were used earlier, but right now these are the one which are being used. Okay, so your next slide will summarize this, that piezoelectric transducer. Here you can see the photograph of portable force platform. So when an athlete applies any kind of force on this force platform, these sensors, yani force transducers, piezoelectric force transducers within the plate distort, causing measurable voltage changes from these sensors, and that can give you idea about force. In a properly constructed force plate, these voltage changes are proportional to magnitude of force applied. The more the force is, more the change will be in the voltage and more signal you will get. So this is the thing. And third important about these force platform is that they can measure your force in all three planes. That is the beauty of the technique. One is your main vertical that I have already told you, that is very important for your strength and landing impacts. And other two planes like sagittal plane and frontal plane, on in those plane also the forces get recorded, and these force data helps you to calculate about chances of injury is there or not, how balanced you are, how good your posture is. So that two forces helps in that. Now coming to force platform, you already know about it, so this is just a revision of that. So I'll cover here what is force platform. So force plates are tools used for measurement of ground reaction forces, and force platforms are based on all three Newton laws. You all know how. So as you jump, you break your inertia, so that is first law. So then when you jump, you apply force, maximum force, so to get maximum height, so that is second law, F equal to ma. And the third law is there, when you jump you get opposite reaction from the ground, so reaction. So all three Newton's law are being followed by force platform. It is based on that, and it is a gold standard tool which will help you to analyze movement like walking, jumping. Secondly, if we know the frequency, so frequency is always known. We set the parameter like 500 or 1000 is the one what is frequency? Frequency means how many times that force plate is going to measure your forces in a second. If we set the frequency to 500 hertz, so that means it will going to measure 500 times in a second the force is being applied on that. So for more frequency is there, more data will get out of that and more accurate it is. So it is always considered to use uh, up to in the range of 500 to 1000. That is the set frequency we use for the research and for the more accuracy. Okay, and it starts from the 200. Basically 200 is minimum. Below that if you set, so that won't give you good data. Second point, I make it clear that if you increase the frequency, the heavier file, you will get more data out of that, and it will be more accurate, and it will cover more space on your PC. So that is the thing. But usually the best range is from 500 to 1000 hertz. This is the frequency they set for measuring athletic movements. And with trigonometric and simple mathematics and the equation of uniform motion which we have already discussed, according to those equations and mathematics, this force platform software will give you velocity, power, displacement, temporal parameters, light left right asymmetry. That this is also possible with bilateral system, so that I'll discuss later on. So this is the main things which it do, force platforms do. Okay. Now this is just an idea to let you know, but you already know all these things. So what are force platforms? They look like this, and in this way it gives you force recording in all three planes. Now moving to two new things. I think you don't know right now. If you are know, that's fine, that I'll repeat it. So basically on the basis of axis, there are two types of force plates. One is single axis, and second one is your multi-axis force. Okay, so what is the difference between the single axis and multi-axis force? The single axis measures your only vertical component of your force, and these are cheaper ones. But in the athletics lab where we are dealing with sports or athletes, there we use multi-axis. So multi-axis means it can record your forces, reaction forces in all three planes, and that is very important because for your to detect your posture, to detect your symmetry, so that is required. So multi-axis systems are used in the biomechanical lab which are dealing with sports. Now they are on the basis of configurations. There are two configurations of force plates. One is unilateral system, second is bilateral. So what is the difference between the two? Unilateral system of force plates involves installation of only one plate. So in our lab also we have only one plate working, although there are two plates there, but only we have only one. So that means we are in this, we have this configuration, unilateral system. When you are using one force plate and there is only one force plate installed, that means you are having unilateral configuration. And second one is bilateral configuration, in which you use two force platforms side by side, and both are working and both are recording your force curves. So what is the significance of bilateral? That will give you symmetrical analysis. So what is the difference between your left side and right side, left leg or right leg? So by this way, when the athlete jumps on these two plates, we get the data of both left leg and right leg, and we can compare it. Is there any problem in the strength of both legs? So that will give you symmetrical analysis. If there is any asymmetry, we can correct that, because if there is some change in these curves between the two legs, so that will lead to injury and also can decrease the performance. So if we work on that area, if we are able to improve the symmetry, we can definitely prevent injuries and as well as increase performance of the athlete. One thing I think I want to make it clear, you can do this symmetry analysis in the single platform also, single force platform, but in that case you have to consume more time, because you will allow the jumper to jump with one leg, again jump with second leg, so that's to measure the symmetrical. But that is not so accurate also, because sometimes some changes happen the way jumper jumps. So it is not natural thing now, you are jumping with one leg. So for to study symmetry, we definitely needs bilateral system. Okay, so that is the thing. I think it is clear. So single axis, multiple axis, these are types of plates. So single axis are right now nobody uses that, because we want other plane force reaction also. So multiple axes are used, and in the modern labs almost we have bilateral systems, so that we can study symmetry also. So that's it. Now coming to the practical areas of application of force plates where these force transducers are used. What are the key areas of application? The first point, please focus on the first point, is designing training or designing workouts. So what is that? So in all international labs, they start the workout by performing this force platform test, because this test will give you an idea about an athlete before training. So what abilities he has, where he is weak or where she is weak. So you can work on those areas. So just by takeoff force, you can get idea of its lower extremity strength, how powerful he is from the lower extreme, in the how good leg power is. Okay, so you can design strength exercise for those particular athletes which have less strength in leg areas. Secondly, by same jump you can get an idea of landing impact, so that could lead to injuries, right? So you can also design plyometric workouts also. So the first and foremost thing is training in each game, and by using this particular technique, force platform tests, you can design right away which athlete needs which workout. So you are not going to just everybody do plyometrics, everybody do strength training, so that will the waste of the time, if already some players are already having good strength, and is again doing same strength training, so what is of use? So in this way coaches can design their workouts by initially testing by using these tests from the force platform. Second is monitoring of training effectiveness, how effective your workouts are. So that is the second part. So once you get idea about the players, by initially that which player, which athlete wants, which athlete needs what. So after giving that, you can again repeat the test, and you can see whether that landing impact has been improved or not, whether strength has increased or not. So in this way, this is the backbone of every game, that you should give a training, a specialized training, a specific training to each athlete, because I have already told you that biomechanics of each player is different. So each player need different workout, nobody is same. So how you can make it personalized, how can you make it specific? By using force platform. So that is the uh, thing, it is a gold standard technique for training also. When you start training, start this test and get to know what athlete wants, and then give him that workout so he can train accordingly, and then you can see the results. So this is the first point. Second is return to play protocols. What is that? That is rehabilitation. If you have some injury, suppose in the game you got some injury, then you are recovering, then you have to see your performance. By using force plate, you will get accurate data that whether you are again fit for the game or not. Because the tests here are very simple, just you have to jump. Most of the tests involve jumping or walking or running, that's it. So these tests are very simple and very reliable and very accurate. So, and crucial point here is you cannot cheat it, because if you are having injury and you are not recovered well, you cannot jump to that extent, and if you try to cheat you will have some pain. So definitely no player can cheat it. So that is the beauty of this technique, that it is very reliable, very easy to do, and very accurate. So return to plate platform protocol is the second area in which force platforms are very effective throughout the world. And third is athlete screening. So screening means you have to screen fresh players for your games. So you can screen using these tests, because some players have inborn abilities, so you have to work less on them to train them. So you will definitely, if you do this test for the screening, you get to know which players are good enough already, so that you can train them more in a lesser time. So athlete screening is the third area. where these platforms are very effective. And overall, what is the main aim of force platform test is to increase performance of an athlete and to prevent injury. So in both area, it is doing very well. So that's why gold and this force platform is a gold standard technique for athletes or in the sports. Okay, I think I've given very comprehensive practical application of this through this slide. So in the next slide, I'm summarizing it all uh, in one go. So force plates are excellent tool for measuring athletes because of their validity. Validity means they are valid throughout the world. They give accurate information. Second point, tests are very simple, like jump tests. They are very repeatable. So you can jump every time. There is no issue by the athlete that I can't perform that task. That is very hard. So for example, in 3D motion also you have to wear sensor and all that. So it is hectic sometimes. So play athletes don't want that repeat. But in the here you have to just jump. So it is very easy to do that. And third, it is very reliable. It gives you good result, effective results, and they are accurate and validated. So that's the beauty of this technique. Third point, it is impossible to cheat a jump test. What it means? It simply means that if you have some injury, you cannot hide that by jumping, because when you jump you will definitely hit that portion and you will have some problem. So you cannot cheat this test. Number four, no sensor interference, that you don't have to wear anything while performing this test. You can give your best without any interference. So that's and so that is also very important. And setup time for each individual is not so much in this. Just you have to make the machine plate ready, get the biomechanics like means there, you can analyze, and you can measure a lot of players because they have to jump only. So that is the thing, that's why it is gold platform. Now in the next slide, I have shown you the curve, so you get some revision. So this is the way he's jumping, counter movement jump. So this is the way you get the curve, which will have all the information. So that is takeoff. The first peak is your takeoff, then that green part, the arrows showing there, is your flight time, and the last curve is your landing curve. We call it the landing impact. So on the basis of all these three, you will get the different parameters. Sorry. So you should have good takeoff force, you should have good flight time, but you should have less or moderate landing impact because it could lead to your injuries. So this is the way you can analyze. So I have already given you in detail how we can analyze in the practical of this force platform, so I'm not going to discuss here that. Now coming to the second part of this non-imaging sensor wearable biomechanical tech. So what is that? By name you understand wearable, that you can wear. The things which you can wear and the things which give you information by wearing them are known as wearable biomechanical tools or biomechanical tech. So why wearable technology is important? Why they have invented it? So these are the 4 or 5 reasons that make them very important from the sports point of view. First of all, a laboratory testing limits how athlete performs, as the environment is not is little bit different from the actual training environment or your game environment. So somehow you get some, this is a human nature. Sometimes when there's a lot of cameras are there, and if you know that testing is going on, you are not in the field actually, you are in the lab. So somehow some reading lapses there. So that is the reason they have invented this, that players should wear that and go to the field and play freely and perform freely in that particular environment in which he is going to play in actual competition. So this thing is done by these variable technologies. Second thing, in addition, performance characters are further augmented during competition. Now what they do these days, they allow the athletes to wear that and then they do inter competitions, because when you're in the competition you do your best. Okay, so when you are wearing that sensors and doing your best, you will get the true performance value of yours. Your true performance analysis is there in the competition. So that competition can only happen in the field, and in the field you cannot take laboratory, or in the laboratory you cannot do competition. But with the help of these wearable technology, you can allow athlete to go to the field and do competition, inter competition with their own players, so that you can pinpoint his actual performance in the field, and that will give you very good analysis, very true analysis of a player. So that is the reason they have invented this wearable technology. You just wear that and go to the field and do the competition, and that sensors will automatically measure the data, and then after that competition we can analyze. So that is the beauty. Third, by better understanding athlete performance during the competition and training environment, coaches can more effectively work with athletes to improve their performance. So when you get that data, which is crucial in the field, that you get by these wearable technologies, so that can definitely help you to enhance your performance more. And how it is possible now? This is possible due to the microelectronics. What is that? This is a special branch of engineering, electronic and engineering, in which everything has become so small. Like our mobiles, you can see earlier there was so big TVs, now TVs are so slim. So mobiles can do everything, you know. So in this similar way, this whole laboratory apparatus have been made in such a small sensors which you can wear and do the analysis. They can do many things. So I will let you know what are these right now being used. And one thing again, I make you clear, very clear here, that the accuracy or the data which you get out of these wearable technology is not comparable to your gold standard techniques like floats platforms. So these technologies cannot replace force platforms, but they are to have some another dimension. Means you can have some idea of these to enhance your information about a particular athlete, but they cannot be done for all players, because how many sensor you can get, so it is not feasible practically. So practically and by accuracy, still forge platform is the gold standard after that vision analysis. So this is your, for your information, you always keep this in mind. You cannot replace force platform with these devices, although you can coordinate their information, you can add up so that you can get comprehensive data. Means you can enhance your data by getting additional data by using these, but you cannot replace it. So please keep this in mind. So the first one in a wearable technology is wearable EMG suits, which uses these EMG sensor. EMG is what? Electromyography sensors. In the earlier days, it is very cumbersome and very difficult to attain data, muscle data of each body part. And secondly, during movement, even sometime you're in the complex movement, it was not possible to record your muscles which are actually firing. Some deep muscles which are firing, you cannot get any idea earlier. But with the help of these wearable devices and sensors, and she is wearing on the thigh and the legs. So by wearing these sensors, EMG sensors, you can accurately get which muscle is firing during a movement. And this data sometimes, most of the time, they integrate with other connected data like from force platform or from 3D motion analysis. So they integrate all these three information and get a clear picture of everything they want, like which muscles are firing, which what are the angles. So to get a comprehensive information, you can coordinate this data with other techniques also. So the latest advances enabled the gathering of muscle data in sports, which initially proved which was very difficult earlier. So for instance, in track and field athletics, it is much simpler to gather muscle data now by using these EMG sensors. So tests can be done to gather information on muscle fatigue, performance, rehabilitation, and injury prevention. So these are the areas where these sensors help. So next slide tells you about coordination of these sensors with 3D motion analysis. So that will give you more comprehensive image, like you will get kinematics data, You will get acceleration data, mainly kinematics. You will get kinetics data by force platforms, and muscle data by EMG. So all these three information get uh, coordinated and get collected, and you will get the final result, which is very comprehensive, and that will help you in research also and enhancing your performance also to another level. So that is the thing which you aim to. Otherwise it was not possible before that. Okay, now it is possible to integrate these EMG. So there are some suits also where you, if you want to just focus on the only on the muscles, you have to just wear that suit and just do the workouts. And it is connected to your phone app. On the phone app, you will get your map of your body, and you will see which muscle you are firing. So this is the latest technology they are using. They are involving mobile apps also, along with these body suits specialized for EMG. And this photograph, you can see the sensors he is wearing along with the active markers. So active markers, I have told you in the previous lecture that they are used for 3D motion capture, and these are the most accurate ones. And this guy is also wearing EMG sensor along with the black one, you can see here on the thighs and on the legs and even on the feet. So these are the EMG sensors he is wearing, and the glowing ones are the active markers for the motion capture. Now coming to the second type of sensor which is being used, we call them as inertial sensors. So these are the latest gadgets in the world of sports, and which give very good information about an athlete movements. So what is so important about these is, and what is unique about these sensors is, they are so small but they can measure your force in the ground in the real time. They can give you acceleration information. They have got gyroscope inside so that they can measure your rotation, okay, angular motion, all that. And they have also equipped with magnetometer, a very small magnetometer, which can measure your body orientation. So all this crucial data, four things I have told you: force, acceleration, rotation, and body orientation. All these four very crucial data is given by inertial sensors right away from the field in the real time, and it's same, it get recorded also. So that is the beauty of this technique, that in the field by using inertial sensors you can get such a crucial data. So these sensors respond to minute changes in the inertia in the linear and radial directions, and these are known as accelerometer and gyroscopes. So this is a technical name for the instrument which are separate earlier. Now they have integrated all these in the form of very small packages. By using microelectronics, they can put all these four in one sensor, which you can see on the right hand side in the foot. He's wearing this inertial sensors. So this is one part. Second part, inertial markers are also there, which we use in the 3D motion capture instead of your visual markers. So these markers can also create your 3D motion model so that you can get studies. So what is the advantage? The advantage is real time. In the field you can get that data. So now coming to the application part of inertial sensors. So the first one is, one of the most popular use of inertial sensor is to quantify athlete readiness. Readiness means how he is aware of, how accurate and how fast he is in responding to different situation. Readiness, how ready he is, how ready athlete is. And second, fatigue, right in the field. So data collected by sensors is incredibly sensitive to detect changes in the force application, because as you react, you apply force instantly. So that changes in the force right from the field can be recorded by these inertial sensors. So that will let you know how alert an athlete is, because alertness is also a very good parameter for, in the scientific term we call it reaction time, how reactive you are. So that thing is measured by with the help of your change in inertia by using these sensors, and they give force data also. And if there is some problem, you can also get to know that there is some injury or fatigue is there in the athlete. So these things right from the field can be only achieved by these kind of sensors. Okay. Third point, in jumping sports, it is very crucial to know how many times an athlete has jumped. So by manually it is very difficult and time consuming for the coach also and for the analyst also to record that data. So by these inertial sensors you can just put that on the athlete and it automatically records each and every jump. And even they have algorithms in means they are so smart, they can even sense which which foot of yours have jumped. They can be even sensitive to your left side and right side also. They have some algorithm and smart sensor inside, so they can learn by just by wearing first time that this player makes such kind of force changes when he moves right side or when he moves to left side, so it get recorded to for that particular athlete. And second time if he does that, it automatically detects that. So this is the beauty of the technique. It can even differentiate between your left side and right side, right during the game, right in the real time. So that is very significant when you analyze motions in right in the game. And last point are that they are also used as markers in 3D motion capture. In this, so these are the, I have told you earlier in the last lecture, one are active marker, one are passive markers, third type is markerless, and these are fourth inertial markers. So using those markers we can also get the information in the 3D motion capture. So this is the last application of these inertial sensors. I think it is clear now that they are very useful. But one thing I make it clear, they are not gold standard because they cannot match the accuracy of force platform and other techniques. But they are very convenient and they have other application. They can enhance your information in real time. So you can get the information in addition to your main analysis and then match it and collect more information about an athlete. So that is the beauty. Now this is the last portion of the lecture. This is a manual Goniometer. So this is traditional method, but it is your syllabus, so that's why I'm telling you. Still some labs use it because it is very inexpensive, very cheap. So on the right hand side you can see that's three sets of goniometers. So these goniometers, what they do, they basically measure angles, and by measuring an angle they give you range of motion of your joints. So this is the main use. A goniometer is a tool used to measure the range of motion of various joints around the body, and it does it by measuring angles. So there is a set angle of each joint which for which you can rotate it. So that you can measure it with this goniometer. They are depending on your different bones and all that. We have three sets of different lengths. So for example, if you are measuring on your arms, you can use middle one. When you are using joints of your leg or hip, you can use larger one. Depending on area, you can use any three of them, and they basically going to measure the angle. So there is set limit of angle for each joint. So if it is if that angle is less, that means you have less flexibility and you have some problem in your movement because you are not using joint to full extent. So that you can monitor. So it is very useful tool for measuring the flexibility. How? By measuring the angles. You will measure the angle, or that is give you what range of motion. So some players can for example, suppose your arm can rotate up to 180-degree from the elbow, right, from the elbow joint. So 180 is the limit. So if it is not rotating up to 180, so there is some problem, and there is some problem in the range of motion. So that gives you an idea physically about all joints where we are able to measure the angle by these external devices. We call them as goniometers. So they are used by physiotherapists, physicians, physiologists, sports scientists also. So this is a traditional equipment basically. Now they are digital mobile apps also, you can do that. So I will discuss them. So this is the procedure how you do. So to measure the range of motion of a joint, you have to locate axis of rotation. For example, here they are analyzing ankle joint. So you have to put that center of circle there and then just to measure the angle and record it. The measurement is the angle in degrees as read off by the goniometer. So then just you have to compare it with the standards that much angle is there or not. If some problem is there, so that means range of motion is affected. So that's in this way directly you can pinpoint that joint is working properly or not. So in the next slide you will see the mobile apps are also there which can do the same thing without using these. They have some sensors, like you can use this app. This is known as G Pro, Goniometer Pro app. So you can download it, and just you have to put your mobile parallel to the joint where it is going to rotate. For example, here you can see the example. They have put mobile right here parallel to the arm. So in the next tab, so this is the 0 degree position. Now he has rotated that uh, arm. So this arrow will give you that angle that got recorded in the mobile app. So here you can see the 104 degrees coming. So this is where you can use mobile app also for this measuring the flexibility or measuring the range of motion using Goniometer. We call it Goniometer, and the app is Goniometer Pro. Now, in the last slide, what are the disadvantage of using Goniometers? So, main disadvantage is that you cannot pinpoint always the axis of rotation because it is not clear. Second point I have told you first. The axis of rotation is not, sometime you cannot pinpoint that, yeah, that is the axis of rotation of your joint. So in that case, you cannot measure properly the angle. So there it fails. And another disadvantage is that you have to be very stable during the measurement. So if a player moves his leg or something, so it will alter the angle. So that will hamper your correct measurement. So these are the two minor, you can say, cons of this technique. So this is it. So this concludes your today's lecture about non cinematography or non imaging techniques which we use in biomechanics. So that's it for the today. If you have any question, you can ask me, and please share your experience in the comments. Thank you very much, and thank you, ma'am, for being here. Thank you. Welcome, Dinesh. Welcome, Michael. Sure, I will share this both the files today. Okay. Thank you.